We're going to go back and now revisit gravity. And as it says here, we are going to study universal gravitation. Universal gravitation is an understanding of gravity that Isaac Newton gave us and extended the concept of gravity beyond the surface of the earth, sometimes stated into the heavens. In other words, Newton showed mathematically that a theory of gravity could be used to explain the motion of the moon around the earth and moon around the sun, the motion of the planets around the other planets around the sun. And it was all consistent that same theory would boil down to what we already know happens near the surface of the earth. That Galileo showed us the acceleration due to gravity is 9.8 meters per second squared on any object, regardless of the mass of the object. And I think it's worth pointing out here the independence of the mass, because what we saw, what Galileo showed us, and then Newton through his second law showed us, that near the surface of the earth, the force due to gravity, we said, was mg. So if that is the only force, because we're neglecting air resistance or any other forces, so the only force acting on the object is directly proportional to the mass of the object, then by Newton's second law, F equals ma, the mass cancels and the acceleration of the object will be independent of the mass of the object. Now, near the surface of the earth, the acceleration is also constant. We'll see in another page of notes that Newton is going to realize we needed to modify the force equation mg, and the acceleration will no longer be constant, but it will be independent of the mass that's falling towards the earth. Now, we also extended our understanding of gravity to include energy considerations, so I want to mention that for a moment. Our energy for gravity, the potential energy given to us by the gravitational field of the earth, corresponded to mgy. Sometimes we replace the y with an h, the height above the surface of the earth, and that equaled a number of joules, right? So a number of joules of potential energy that we saw as the object fell to the earth was converted into kinetic energy. And this we all know to be true. When I say we know it to be true, it is experimentally verifiable. It is true. Near the surface of the earth, the acceleration due to gravity is a constant negative 9.8 to a very good approximation. It is equal to mg equals ma to a very good approximation. And the potential energy, the energy is converted into kinetic energy according to mgy or mgh. So whatever we are going to learn about Newton giving us, please keep in mind, it must collapse, converge to show that these equations are all valid to a very good approximation, or Newton's equations itself would not be consistent with what we know to be true. Okay, now I have here that one of the reasons we should expect our current understanding of gravity to need to be modified. Now, I use some stronger language here, to fail as we move further from the Earth's surface. And by further, let's go out to infinity. So to see really the unreasonableness of it, if we went out to infinity, we would essentially be saying that it doesn't matter. The acceleration due to gravity we still expect to be negative 9.8, and that it doesn't matter where you go, the acceleration due to gravity from the Earth will be the same everywhere. And it's possible, I guess, that you could still believe, well, that might be true. But as we're going to see, what Newton showed us was that he took his new understanding of gravity, and used it to explain all of the data we had on the motion of the moon around the Earth and the motion of the planets in the solar system. So what Newton did was show that not only is that probably a pretty unreasonable expectation, even to think, intuitively that it could happen, mathematically, you can't use that description of how the world works and apply that description of gravity to say this is how the solar system works and have it match the data that Brahe and Galileo and the astronomers had given us, and to match Kepler's law. There's a lot more here to talk about. And to give you a sneak peek ahead of also what we will be looking at, if we look here, I have at the bottom of the page just a quick kind of glance ahead to get us thinking in the right direction. If we take our normal potential energy function, by normal I mean the one we now understand, mgh, and extend that out to infinity, what we would be saying is that if we dropped an object, put an object down here at infinity, we would see that potential energy, those joules converted into kinetic energy, as if we were right on top of the Earth's surface here at the radius of the Earth. What we will see, again, I'm stating it without proof, but we will show the proof of it in our notes in a couple of pages, is that the potential energy function is really given by this 1/r dependence, where if we do place an object down here at infinity and release it, we're essentially on a potential function plateau, where that's a neutral equilibrium spot. It really won't roll left or right. Certainly if we move in, it does begin to roll a little bit, and we'll convert more potential energy into kinetic energy and more and more. And down here, notice that the two must converge. Please make sure you get this a bit into your notes. It is important to understand that anything Newton gave us must be consistent, ultimately, with what we know to be experimentally verifiable near the surface of the Earth. So there is so much more here to talk about. I am looking forward to going through the rest of the unit. Hopefully you will find it interesting, because it is very interesting. More to come.